Okay, so here we have a classical capacitor question. The switch is closed. Okay. And indicate how the current in resistor A compares to the current in resistor X. If either current is 0, be sure to indicate that as well. Okay, so here we have two situations immediately after the switch has been closed. So look, the current is going to be leaving the positive terminal. It's going to be going through X. That means that X does not have a 0 current, at least for now. The switch has been closed. Now the current is going to reach two junctions, and it either goes through both or only goes through one. Now because the switch was just closed, that means your capacitor is gonna be empty. And if your capacitor is empty, the current would rather go through the empty capacitor than actually go through the resistor. So what it does is that it's going to, skip A. So the current is going to skip A and it's going to go straight toward the capacitor because it's empty. And then it's going to continue, and then it has a choice to either go through Z or to go through this wire that takes it to, again, an empty capacitor. And it's going to do just that. It's going to go through the wire that takes it toward the empty capacitor, therefore skipping Z. Then it's going to go back. So what we just saw is that the current skipped resistor A, and the current skipped resistor Z, but the current can't skip resistor X. So IX is not 0, but IA is equal to IZ, which equals to 0. So IX is going to be bigger than IA, and IA is going to be 0. Okay, how about a long time after the switch has been closed? Now what this basically means is that our capacitors became fully charged, and they simply now can't let any current through them. So let's go back here, and now my capacitors are fully charged, and also here fully charged. Now what happens is the current's gonna leave this positive terminal. It's gonna go through X. The switch has been closed. The current keeps going, and now of course the current cannot go through the fully charged capacitor. It has to go through A. Then it has to, either go through the fully charged capacitor, which it cannot, or it has to go through Z. So it's going to go through Z. Then it's going to go back all the way to our terminal. So now what happened is the current did not skip any resistors. In fact, now the same current went through all the resistors. The same current. That means that all the resistors had to be in series. So now IX is equal to IA, which equals to IZ. So IA is equal to IX. Okay? That's how we do it.